Hello, everyone. I'm Pawan Khandavilli. I'm from Microsoft Azure. Today, I'm going to do something different. I'm not going to talk about Microsoft products, although I do mention it. But what I'm trying to convey here is how confidential computing will unlock the agentic economy and give some scary numbers as well. So let's get started. So these are the numbers since the beginning of the year, right? So we had more than 750,000 agents compromised in a single night. We had 195 million records that were breached, and it was a single attacker weaponizing Claude Code and GPT 4.1. We had 150 million plus downloads of a poison MCP supply chain, one character in HTTP header, exposing clinical databases, inboxes, SSH access, and a 1-cent transfer memo hijacking a financial AI agent. So these are scary numbers, but one thing that's common is not one of these agents could prove who it was, what code it ran, or whether it had been tampered with. And I see this as not a security problem, but an architecture problem, and that's a problem that confidential computing can solve, and this room can solve. And I've seen this sort of pattern before. So in 2014, I was working for the Royal Bank of Canada, and payments had a trust problem, magstripe cards. They were cloned at scale, and the fix was using EMV chips and secure element attestation. This is what I worked on Apple Pay, Android Pay, and mobile payments. And payments solved the trust problem, and last year we had $2 trillion of contactless payments. And in 2018, I joined Fortanix and Microsoft, and the trust problem was trust our hyperscaler, and the hardware fix was leveraging confidential computing, SGX, TTX, and SCV/SMP, ARM64. And the outcome is 75% of enterprises have started adopting confidential computing, according to the IDC report. And now the third wave is coming, and these are agents. And the trust problem here is OAuth tokens making 10K iterations per minute. And this is the trust problem that I'm talking about. We solved it with payments and cloud, and now agents are coming. And I noticed something in Reddit like a few weeks ago when Visa connected its payment network to ChatGPT. The first and the top reaction was first person to trick the chatbot is about to make bank. And it felt like a joke, but it's also serious. So identity proves who's asking. It doesn't stop an agent that's been tricked into asking, right? So if the model is the thing that can approve a payment, whoever can trick it can move the money. The authorization has to be deterministic and enforced in hardware that the model can't override. So that's sort of the problem that I'm trying to expose here. Coming back to EMV, the first wave, the EMV proof point was after the US chip rollout. Fraud at chip-enabled merchants fell by 76%. So that is what moving trust into hardware does to a fraud curve, and the same curve is coming for agents. And I keep going back to payments because we have companies trying to solve the identity problem. So we had Visa with the Trusted Agent Protocol. We have MasterCard with Agent Pay with tokenized identities. Google introduced the Agent Payment Protocol, again with verifiable credentials, and signed mandates, which is now part of the FIDO Alliance. And then the FIDO Alliance itself, a few weeks back, started the Agentic Authentication Working Group with several important work streams that are important to the agentic economy. But every protocol demands verifiable identity, but none of them specify hardware root of trust. I think that is the missing layer, and that is where our community needs to keep progressing and bring those into the standards. Let's think about an approval path for a payment agent or without hardware guardrails, right? So the user expresses intent, the agent picks it up, it calls the tool over MCP, and the tool calls the payment trail, and the money moves. That's real money moving. And every hop and token is authenticated, but not the code that's actually working on the tokens, not the code that's actually running within these different components, and whether they can be trusted. And if you look at the 1 cent attack again, a normal transfer memo became an agent instruction. The agent reads transaction history as context, and nothing attests that the context is trustworthy. And it's just not these, right? Even the NSA has now weighed on MCP. And what they basically did, they did an analysis on an MCP, and they called for cryptographic identity and verifiable logs, but they stopped short of saying that we need a hardware root of trust. I think that's something that they got wrong, and that's something that we need to keep advocating for. They definitely got the surface area right. They missed the deeper layer, hardware root of proof of what actually running. And securing the endpoint doesn't help when the attacker's leverage is poisoning the context that flows through them. And there's been, lately people are saying MCP is dead, and they framed it as a performance complaint. And that tool definitions take about 10.5% of a Claude's context window. But I think it's beyond that, right? Like, the more context you have, the more there is a chance of it getting poisoned. And MCP puts the tool catalog inside the brain, but it should be behind attestation in the infrastructure layer. And the evidence keeps cascading. Like, as we look through, we had the bad host attack that we talked about. O'Reilly Radar did an analysis. And that's something that really stuck out to me, right? Like, basically, agents can spawn different agents. So when agent A receives a token, delegates to agent B, and that goes to agent C. Each hop reuses the original token or has no token, so it's not traced. And people are doing the right thing. Like, people are building for agent security, right? So we have the OAuth top 10. Even Microsoft built the agent governance toolkit. We have NSA doing analysis, NIST building these agent standards. This is real progress. I think we need all of this. We need these layers to be built. But none of them make hardware the floor. We have the right frameworks, but the vocabulary is fragmenting, and we need to ensure that we bring that vocabulary into all these frameworks and build on a hardware layer of trust. And as I discussed, these are very important controls. Last week, a former VP from Meta and DeepMind wrote about the state of agent sandboxes as a dialogue. And it ended with, let me guess, the guardrail is a prompt. It's a very nicely formatted markdown. Okay. So we're asking the agents to follow instructions nicely, but the controls are wrong there. We need to have deterministic controls that can be verified within a hardware root of trust. And OAuth proves who, not what, not the code that's running. Audit logs are necessary, but they're only tamper evident if the log root is anchored in hardware. Otherwise, it's just under promise. And the hardware attestation layer is the foundation layer that makes all the other layers above it verifiable. Without it, you have governance architecture, and with hardware, you have governance proof. And this is the missing layer. I've categorized these missing layers into sort of 4 gaps that we need to work through. So the first one is attested agent identity. So SPIFFE is a great protocol. It proves workload identity, but we need to run the Spire system inside a TE and bind the SVID, which is the identity that's provided to agents, to a TE. 2, attestation is absent from MCP. So we need the MCP servers that deal with a lot of permissions. I mean, agents send permissions, delegate permissions to MCP. So we need to be able to trust and attest that the servers that are taking these tokens and working on behalf of us have the right security and are attestable and verifiable. The MCP spec still doesn't have any attestation or a hardware-based root of trust encoded in its spec. And 3, the delegation chain. RFC 8693 token exchange at each hop, but carrying TE measurements. So agent A to B to C, each hop with a hardware proof. And 4, we need cross-cloud agent trust. We have different hyperscalers, including Azure, GCP, AWS, all building confidential computing. We should be able to work together. CCC is already working on this, and we need to make sure the agents can trust each other within these different clouds. And finally, the MCP spec ships on July 28th, if I'm not wrong, and there's still no attestation layer, and the window influence it is closing. And few other pointers out in the industry. We have Uber, we have academic researchers, we have 1Password, and other teams like building on these standards, right? Like Uber with production agent identity at massive scale per hop RFC 8693 token exchange, but again, there's no TE there. Same with MCP servers. We have this working from researchers, etc. We need to start encoding this in the MCP spec. 1Password and Kika, two vendors, same week, and they ship their credential broker. The agent proves context with a signed badge, and credentials are brokered just in time with no standing secrets. And again, that is software attestation. It's the same conversions. This is all important, but we're missing that hardware layer of trust. So 3 teams working independently converged on the same answer. What none of them has yet is the end-to-end integration, and that is the work that this community has to do. So going back to what we need to build. So I'm proposing a 6-layered attested agent identity stack, right? So layers 1 and 2 are green, and the reason they're green is we have the hardware root of trust and confidential execution. We have production ready. The hyperscalers have built them. The neoclouds have built them. They're ready. Like we've been running these in production for a while now. And this is a very important layer, but when you search for confidential computing for agents, you'll find very good material, but that is just a waterline, right? We still need to build the layers on top. Layer 3 is partial. We are having specs coming up. Layer 4 is the attested tool invocation, attested MCP servers. I know a few folks, even OPEC, have started building these. And layer 5 is something that I think everyone forgets. And this is the authorization and RBAC for agents. And I feel that's a very important missing piece. So this is the deterministic policy layer saying that even though an LLM might want to do something, there should be guardrails that prevent it from doing a specific action that's encoded into policy and attested via hardware. Layer 6 is the audit trail, tamper evident only when its roots are in the TE. And just notice that the confidential GPUs are layer 2. They protect the model, the agent, who it is, what it may do, what it did. But that is just, that is an important part, but that's not the complete part, right? So when we talk about agent security today, there's 3 questions I think we need to answer. Who is this agent? Was this tool called legitimate? And was this agent authorized to do that? Layers 3, 4, 5, that's the work. We have built layer 1 and 2, but I think we'll have to standardize and build the layers 3 and above, and that is where the missing link for the agentic economy is. So let's take the same example that we had previously and put it in a confidential container layer. I work in confidential containers at Azure, so that's a product that I really like. So that's the reason I've just chosen that as this example here. So if you follow the flow here, we have the user intent, an orchestrator with a Spire identity, payment agent with sealed credentials, MCP tool in an enclave mode, and each box is tagged with the layer it implements, right? Like that's the distinction I've been trying to make here. And every hop is an RFC 8693 token exchange. Every tool call is attested MCP in enforce mode. And just to be clear, and this is the policy layer that I've been talking about, right? So the one-send memo, the example that we had previously where we had a financial agent tricked by the context window, attestation does not solve it because attestation can say that the intent came from a user device that is trusted. But what will stop the actual action from happening is layer 5, which is the deterministic policy, which is enforced inside the trusted execution environment, with attestation proving that the policy engine itself has not been tampered with. That's the composition. Attestation proves the policy is real, and policy constrains the agent. And just to be clear, hardware is the foundation, but not the silver bullet. We have attacks on AMD, SCV, S&P, and other side channels on SGX. We have vendor dependencies, different attestation. But the trust here is explicit, right? When hardware trust breaks, the model is explicit. A measurement, a CVE, you reattest. I know it's painful, but it's something that we can reattest. When implicit trust breaks, which is what I call software trust, by the time you see it, the agents are already gone. The detection isn't the breach. So we can mitigate this. I know it can be hard to work through some of these attestation failures, etc. But I think the explicit trust here makes it easier for us to build upon this for the agentic economy. And the market for agents is moving with or without us, right? Like we have the EU AI Act coming out in 7 weeks. I believe the fines start August 2nd if if there's a breach in trust. Sweden put out exploration of TEs, where shifting from promises to verifiable proof, that's GDPR language that Sweden confirmed that TEs do solve it. We have Uber, WorkOS, 1Password, converging on attested identity, and they've shipped the software half, and I think we'll need to work with them on the hardware route, which is still the missing half, and that's what we need to supply to them. And we also have Apple shipping PCC on Google Cloud. So the market is moving pretty fast. The agents are coming, and we should be ready and work with these folks to build the hardware trust into the stack. So how should we take this? What is the call to action here, right? If you build agents, the architecture is public. We'll need to start adding the TE boundary and the workload identity into it. And for folks who are writing frameworks and standards, 6 major agent security frameworks are in flight, and none of them require hardware attestation. We'll need to fix it. We'll need to work with them to get hardware as a floor for the most sensitive workloads. And I proposed something myself. So we have the Microsoft Agent Governance Toolkit, and I've been working with the maintainers to build in confidential computing and support for it. And the toolkit's advanced conformance tier already rejects software-only keys. So agent identities need to be inside hardware-based key stores. And if you can care about this, that's the URL. Please contribute and help us build this. So as I mentioned, I watched 2 revolutions before. The wave 1 was payments. Wave 2 was the cloud. And wave 3 is agents. And if all of these waves are following the same path, we have innovation first, trust later, and eventually hardware is where the trust started to come through. The difference this time is that we are not late. We have built the primitives that are needed. The builders are publishing the frameworks right now. The regulators are ruling right now. And the only question is whether the trust layer ships before or after the breach that makes 750,000 looks like a rounding error. So my ask is, this room has built every confidential computing primitive. Let's make sure the agentic economy is built on it and not beside them. Thank you. I think I have time for questions, so please go ahead if there's any questions. Go ahead. I'm sorry? Yes. There we go. Okay, sorry about that. OAuth, yes, with the RFC. I keep forgetting the RFC number. But I think we'll need to add the TE attestation to the spec. I don't think it's there yet. We'll have to try and extend it to have the hardware attested identities as part of it. But I believe like it is a good foundation to build on. Yeah. I mean, I can just go through, like, I know I flew through a few points, so I just had a few backup slides. So I think one of the things that I discussed, that attestation does not stop everything. And essentially, like, attestation proves the identity and integrity, but it still does not stop the LLM from being tricked, right? So I think that's the layer that at least I've been trying to work on, which is the deterministic policy enforcement. And this is what we're trying to build in the agent governance toolkit, where even though the LLM can be tricked, we want the policy, for example, let's take the example of a payment, right? If we want to encode in a policy saying that the agent cannot do transactions beyond $1,000 or some deterministic policy that we want to enforce, that's the policy layer I feel that's missing, and not a lot of thought is being put it. So attestation doesn't stop everything, but we are trying to put layers that essentially can deterministically stop LLMs from doing something they should not supposed to be. So yes. So if you go to the Microsoft Agent Governance Toolkit GitHub, there is a sample there. It's not completely running in confidential. The primitives are there. We're trying to like get that up and running. But yeah, if you go just search for Agent Governance Toolkit, there are policies for payment apps. Like, I think there's also a Stripe example, like connecting to a Stripe MC server. What we're trying to do now is we build the primitives, but the compute layer on where it's landing is what we're building. It's, again, all open source. We're building support for Azure first within that framework. But yeah, that's not stopping from any other cloud provider to start building on it. But yeah, I can send you the URL. It's essentially all the sample apps are there. Yeah, yeah. Okay. Right. Yeah, go ahead.
Yeah, so I'm from one password, and I have to be a technical leader of my company for that feature.
Okay, that's good. I'm sorry. I hope that's accurate what I described. Yes. Yeah.
I'm curious from a hardware application perspective. We're application level developers. We're not thinking too much about policy and that. Specifically, that feature is credential access. Not writing models. It's just models or first iteration GitHub actions to retrieve credentials from your account. What value do you think that hardware attestation provides for an application like ourselves to including geographic values that say evidence of an API secret?
Uh-huh.
In this case specifically, the unique API secret is generally using the file identity to make access systems.
Okay.
So you arrive at identity that key necessarily
Okay.
But from an application level, as an application provider,
Yeah.
what value do you leverage by having knowledge of hardware access on the agents that are requesting?
So where, I mean, it could be more of, so if the agents are running within a TE, right, where you could, it's outside of a class. Yeah. So where if you're running within a hardware attestation, right, so the key is essentially the identity of the agent, I'm assuming, right, that they sign identities with that. So what, at least in the governance toolkit, what we're doing is for agents that require a higher level of authentication, the key never leaves the hardware. right? So, and it only leaves if the agent is running within a known state, which is a trusted execution environment. So in your case, I think running the credential guard, I forgot the exact name of the broker within TE, and tying that to like ensuring that the keys ever released only to an agent that's running within a TE, that would be the different layers of trust. Like for applications that we need to prove that haven't been tampered with and cannot spoof our identities, that's the kind of connection that, like, we can discuss more offline, but that's where I see that. Yeah.
I think in our case, it's running
Yeah.
on like your device, for instance,
Okay.
or maybe in a back or something like that.
Yes.
So it's running on someone else's.
Yeah.
It's taking the first asking.
Yeah.
Okay.
Okay.
So I think that's
Yeah. Yeah. Sounds good. All right. All right. Thank you so much, folks.